So how far we have completed in last lecture? Which numerical? Huh? Ball drop. Ball is dropped from 30-meter height. Solve झाला होता का पूरा प्रॉब्लम? Okay, so one more problem of that type we will take. Stone is dropped. Stone is dropped from top of the tower. From top of the tower 50-meter high. 50-meter high. At the same time, another stone is thrown from the foot of tower. From the foot of tower with velocity of 25 meter per second. Full stop. When and where these two stones cross each other. Okay, so the problem is that a stone is dropped from a tower of height 50 meter. So if I draw the diagram, suppose this is a ground level. This is the tower which is having a height of 50 meter. The height of this tower, this height is 50 meter. So this is 50 meter. Now a stone is dropped. Suppose this is a stone. This is a stone which is dropped from here, this 50 meter height. It is dropped from here. And another stone, this is the second stone, which is thrown vertically upward. This is thrown vertically upward with a velocity of, so its initial velocity is 25 meter per second. Okay, so this is thrown in this direction. So the question is when and where they will cross each other. Okay, so we will say that at this point, okay, suppose at this point they will cross each other. This is the point where they will cross each other. It means that this stone will come over here at this point, and the second stone will reach to this position. Okay, so at this pink line they will cross each other. So the time for both the stones is same. Okay, time for both the stones is same. Suppose in 2 seconds it will come at this level. In 2 seconds, this stone will reach to this level. Okay. So first of all, consider first stone. Consider first stone. Let us say that this is our first stone. This is second. This is second. So first stone. Now, if you consider the first stone, then what is initial velocity? What is initial velocity for this first stone? It is drop. What is 0? It is just drop. Then what is this height distance travel? Suppose I assume that the second stone travels a distance, this distance travels, or this height which is traveled by second stone is h. If this is h, then this will be 50 minus h. 50 minus h. Okay, so for first stone, I will say this is u1. For first stone, h1 is equal to what? It is h. Okay, you don't know. Then g is equal to, sorry, not h. h1 is equal to, h1 means this height. It is 50 minus h. Then g is acceleration due to gravity 9.81 meter per second. It is positive because it is moving down. This is first stone. And time is t second. Okay. Time is equal to t second. So now if I use the formula, h is equal to ut plus half gt square. If I use this formula, then here h is nothing but it is 50 minus h. h1 येणार ना इथं. Okay. h1 is 50 minus h. Then u is 0 plus half into 9.81 into t square as it is. Okay, so you will get one equation in h and t in terms of h and t. What is that equation? This 50 minus h will remain as it is, which is equal to, this is 4.9 t square. This is your equation number 1. This is the equation number 1. Now think about this second stone. Second stone. So to consider second stone. Consider second stone. Okay. Now if you consider second stone, u2 is the initial velocity for second stone, which is given as 25 meter per second. Okay. Then height. Okay, h is equal to, what is the height for second stone? This is h. Okay, height is equal to h. The height for second stone is equal to h. Then g is equal to minus 9.81 meter per second square. Why it is minus? Because it is moving upward. That is why this is minus. Okay. So if you use the equation, your equation will be h is equal to ut and half gt square. As the value of g is minus, this equation will become minus. So put the value, h is nothing but h as it is, equal to u is 25, t as it is, minus half into g is 9.81, okay, into t square. Time is t. Here time is same. Time is equal to t seconds. So now if you solve this equation, what you will get? Here h is equal to 25t minus 4.9 t square. Okay, 4.9 t square. So this is your equation number 2. So put the value of h from equation 2 in equation 1. Okay, from equation 1 and 2. What is your first equation? Your first equation is 50 minus h is equal to 4.9 t square. So I will write here 50 minus h means this value. H is equal to this value is there. So I will write it in bracket 25t minus 4.9 t square. This is the value of h, which is equal to, it is 4.9 t square. So in the first equation, I have put the value of h from second equation. This is the first equation. Here the value of h, I have taken that value from second equation. Now what will happen? So here 50 minus 25t plus 4.9 t square is equal to 4.9 t square. So this 4.9 t square will get cancelled. Okay. And what is remaining? 50 is equal to 25t. So therefore, what is the time now? T is equal to? It is 2 seconds.
2 seconds.
So time is T is equal to 2 seconds. See, we are not doing anything extra. Just we are using the equations of the motion. That's it. Okay. Very simple problems are there. These problems are very easy. Just you have to put the formula. You have to see the values, and you will get the answers. So when, so the answer of question when and where. So in that the answer of when is with us now. Time is equal to 2 seconds. When the after 2 seconds they will cross each other. Then where they will cross each other. So height also we need to calculate. Okay. So from equation 2. So if we put the value. So here I can write from equation 2. What is the value? H is equal to 25t minus 4.9 t square. So put t is equal to 2 seconds. Therefore, h is equal to, it is 25 into 2 minus 4.9 into 2 square. What is the answer? 30.4. So it is 30.4 meters. Okay, so at this distance they will cross each other. Okay. Is there any doubt in this numerical? It is similar to previous example. Just we have changed the value. Is it clear? So now next numerical. All of you are doing practice at home. प्रॅक्टिस करताय का नाही? एवढा वेळ मी सांगून का आज वही बंद केली की आजच उघडायची क्लासमध्ये परत दुसऱ्या दिवशी सॉरी आज कसं आज बंद केली की दुसऱ्या दिवशी उघडायची असं चालू नाही ना करू नका असं ऑनलाइन those who are attending online are you doing the regular study?
Yes sir. Yes sir.
If you do the regular study then whatever is going in the class you can be able to understand it quickly. ओके अदरवाइज मग तुम्हाला ते मागचं बघत बसा तोपर्यंत इकडे पुढचं शिकवून झालेलं असतं अजून सो इट विल बिकम डिफिकल्ट टू मेंटेन सो डू द स्टडी रेग्युलरली ओके आज काय झालंय ते आज घरी गेल्यावरती बघायचंच कंपल्सरी till date nobody has asked me the doubt this problem was there which is given for the homework and we are having this and this doubt now almost semester end is there तो म्हणजे मला असं पहिला क्लास वाटते की ज्याच्यात कुणी कधीच डाऊट विचारला नाही हा तुम्ही सेपरेटली विचारला होता एकाच ओके इन जनरल आता 60 मुलांचा क्लास आहे म्हणजे 60 मधल्या दोघांनी विचारला म्हणजे इक्वल टू 0च आहे ते. कळलं का? नियरली इक्वल टू 0. ओके. So now next problem. A motorcycle rushing at 20 meter per second finds a child on the road 50 meter ahead, 50 meter ahead, full stop. 50 meter ahead, not full stop. 50 meter ahead. Okay. Then continue, not full. Then instantly brakes are applied. So that motorcycle stops within 10 meter from the child. Full stop. Calculate the retardation. And time required to stop the motorcycle. Okay, so read the problem and try to understand what is given and try to draw the diagram. If you are able to draw the diagram after reading the numerical, then it will become easier for you to solve the problem. Unless and until you understand the numerical, you will not be able to draw the diagram. A motorcycle rushing at 20 meter per second. So initial velocity of motorcycle is 20 meter per second, correct? Finds a child on the road 50 meter ahead. So after 50 meter ahead, a child was there on the road. Then the brakes are applied. Okay. And the motorcycle stops within 10 meter from the child. So now if I draw the diagram, see, this is the road. Okay. And now suppose this is your motorcycle or whatever. And it is moving in this direction. Its initial velocity is 25 meter per second. Okay. And he saw a child on the road. Okay, he saw a child on the road. Just a minute. Okay. He saw a child on the road. So suppose now the child is standing here. Okay, this is the child. What is the distance when he saw him? What is the distance when this motorcycle saw this child? It was 50 meter. Okay. So the distance between these two. This distance is 50 meter. This is 50 meter. Okay. Then he starts applying the brakes. Okay. Then he starts applying the brakes and then it will stop. Suppose now this motorcycle will stop here at this point. Okay, here it is stopped. After applying the brakes, at this point, it is stopped. So when it is stopped, within the 10 meter from the child, so the distance of this motorcycle from the child, so this distance, how much is this? 10 meter. So this is 10 meter. So I will write here, this is 10 meter. Now what we need to calculate? Calculate the retardation and time required to stop the motorcycle. So de-acceleration we need to calculate, retardation and time. ओके, म्हणजे इथून ते इथं स्टॉप व्हायला ह्याला किती टाइम लागला ते टाइम कॅल्क्युलेट करायचं. नाउ फर्स्ट टेल मी, दिस इज द मोशन प्रॉब्लेम ऑफ मोशन अंडर ग्रॅव्हिटी और लिनियर मोशन? This is the problem of which type? It is linear motion. Okay, here there is no gravity. Why? Because the motion is horizontal motion. If the motion is vertically upward or vertically downward, then it comes under motion under gravity. Okay, so now see here, we want to calculate the acceleration. How do we calculate? So given data is, you know, u initial velocity 25 meter per second. Okay, what is the final velocity? It's a stop hota hai na, here it will stop, so your final velocity v is 0 meter per second. Okay, and what is the distance travel? इथून ते इथं किती डिस्टन्स ट्रॅव्हल झालं इथून ते इथपर्यंत? 40 meters. After 40 traveling 40 meter, it stops. Okay, so s is equal to what? 40 meter. Huh? 20 है क्या? हाँ right, 20 correct. Velocity is 20. Sorry, this is 20. So now what we need to calculate? We need to calculate here what is retardation and what is the time. This we need to calculate. So I know initial velocity, I know final velocity, I know the distance. So what formula I will use? I will use v square is equal to u square plus 2as. So v square means 0 square is equal to u square is 20 square plus 2a as it is into s is 40. So if you solve this, you will get the value of a minus 5 meter per second square. Please check the answer. The value of a is minus 5. Is it right?
Yes, sir.
Okay. If it is right, now next. Now we have got this. Just wait. So we have got the value of a now, retardation. Now we want to calculate the time. So we know initial velocity, final velocity, acceleration also known to us. Now we want to calculate the time. So we can use here V is equal to U plus 80. So here V is 0, which is equal to U is 20, plus value of A is minus 5, and into T as it is. So therefore T is equal to, it is 5 into 4 seconds, no?
Yes, sir.
T is equal to, it is 4 seconds. Is it right?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Problem समझ लेगा? Have you understood the numerical?
Yes, sir. Yes, sir.
Yes, sir.
Hmm? Shall we move forward for the next?
Yes, sir.
पुढचा प्रॉब्लेम घ्यायचा का?
Yes, sir.
Yes, sir.
Okay. The next numerical, write it down. A stone thrown vertically upward the stone is thrown vertically upward from ground with velocity of 49 meter per second. After 2 seconds, another stone is thrown vertically upwards. From the same place. Stop. If both the stones if both the stones strikes the ground at the same time, calculate velocity with which second stone was thrown upwards. Calculate the velocity with which the second stone is thrown upwards. Now calculate this. Solve the numerical. करा सॉल्व आणि मला आन्सर सांगा. The stone is thrown vertically upward from the ground with a velocity of 49 meter per second. So let us say that this is one stone. If I draw the diagram, see this is the ground level. So now this is the stone. This is the first stone. This is the first stone, and this is the thrown with a velocity of, what is the initial velocity of first stone? That is u1 is equal to 49 meter per second. And after 2 seconds, second stone is thrown vertically upward. So after 2 seconds, now the second stone. This is the second stone. Okay. Let us say that this second stone is thrown from here. This is the second stone. Okay. We don't know the velocity that we need to calculate. Okay. This is thrown. The second stone is thrown. Okay. The initial velocity is u2. We don't know. But what is happening after reaching to the maximum height? After reaching to the maximum height, what happening? If the both stones strikes the ground at the same time, see here, they are striking the ground at the same time. So at the same time they are striking the ground. So when this first stone is over here, so when the first stone, it comes near the ground here, at the same time, second stone is also here. Means what? How will you calculate this now? 39.2, correct, right answer. Velocity, no? Correct. Okay. So see how it is happening. Now this is the first stone. When it is thrown, it will move up. When it will be thrown, it will move up to a point where it will get the maximum height. Okay. So suppose this is the point where the height is maximum. This is your first throw. So when it reaches to maximum height, what is the final velocity at this time? 0. Okay. So we can calculate the time required by the stone 1 to reach to maximum height. Okay. Once we know this time, then whatever time is required for this first stone to go to the maximum height, same time will be required by the stone 1 to come on the ground. Okay. So here, what I will write here, consider motion of stone 1. Okay. So here u is equal to 49 meter per second, v is equal to 0 meter per second, g is equal to, it is moving upward, so minus 9.81 meter per second square. Okay. And time is equal to t seconds. Let us say that this is t second time. So the time required to reach here is t seconds. So if I use v is equal to u plus gt, but g is minus here because this is minus. So v equal to u minus gt. So therefore 0 is equal to 49 minus 9.81 into t. Therefore t is equal to how much? 4.99 seconds. Okay, t is equal to 4.99 seconds. So now if the t is 4.99 seconds, so this is the time when this first stone is started from the ground and reached to maximum height. After reaching the maximum height, when its velocity becomes 0, it will start to fall down like this. ओके, इथून हा खाली यायला लागेल, तर मग जाताना किती टाइम लागलाय 4.99. मग येताना पण किती असणार आहे? इट इज बिकॉज इट इज मुव्हिंग अंडर द ग्रॅव्हिटी, देर इज नो एनी एक्सटर्नल फोर्स ऍक्टिंग ऑन दिस स्टोन. सो येतानाचा पण टाइम काय असणार आहे याचा? तीच असणार आहे. अँड द व्हॅल्यू ऑफ टी इज 4.99. सो टोटल टाइम ऑफ द मोशन, what is the total time then? When you throw this ball, it will move up, it will go to certain height, and from there it will again come to the ground. So this is the total time, and that total time will be the time required for the upward motion, that is 4.99, and after the velocity becomes 0, it will move to the ground. So again it is 4.99. So what is the total time? It is 9.98 seconds. This is the total time. Okay, this is the total time of the first stone. म्हणजे जर तुम्ही विथ व्हेलॉसिटी ऑफ 49 मीटर पर सेकंड पहिला स्टोन जर वर फेकला, तर तो परत येऊन ग्राउंड वरती कधी लागेल? आफ्टर 9.98 सेकंड. दॅट इज द मिनिंग. पण इथं प्रॉब्लेम मध्ये काय म्हणलेलं आहे? अ स्टोन इज थ्रोन वर्टिकली अपवर्ड फ्रॉम द ग्राउंड विथ व्हेलॉसिटी ऑफ 49 मीटर पर सेकंड. आफ्टर 2 सेकंड्स सेकंड स्टोन इज थ्रोन. म्हणजे दुसरा स्टोन जो आहे तो किती सेकंदांनी टाकलेला आहे? 2 सेकंदांनी. पण तरी पण ग्राउंड वरती येताना दोघे एकसाथच आलेले आहेत. म्हणजे सेकंड स्टोनचा टाइम काय असेल टोटल जर्नीचा? पहिल्या स्टोनचा टाइम किती आहे? 9.98 सेकंड्स. ओके, then what is the time for the second stone if it is released after 2 seconds? It will be 9.98 minus 2. समजतंय का? Is it clear? समजलं का? What is the time of second stone?
Yes, sir.
नसलं समजलं असलं तर विचारा. Total time of second stone. So total time of second stone means when you release this throw this second stone, it will also move up. It will also reach to the maximum height, and from there it will fall down. This is the total time for second stone, and this total time of second stone will be the time for first stone 9.98 minus 2. So it will be 7.98 seconds. This is the time for the second stone. हे समजलं नसलं तर विचारा. परत एकदा सांगतो मी. समजलं असलं तर चांगली गोष्ट आहे. Is it clear how this 7.98 comes?
Yes, sir.
If you won't understand, then I will tell you another example. म्हणजे ही गोष्ट कशी आहे समजा, suppose now a competition is there. Okay, a competition is there between the two persons. Those who have not understood, please pay attention over here. A competition is there between two persons. Okay, लाडू खायचेत. लाडू 2 प्लेट मध्ये लाडू ठेवले. तुम्हाला खायचेत. एका प्लेट मध्ये 30 लाडू आहेत, दुसऱ्या प्लेट मध्ये पण 30 लाडू आहेत. दोघांमध्ये कॉम्पिटिशन आहे. ओके, पहिल्यानी लाडू खायला स्टार्ट केलं. ओके, फर्स्ट पर्सन, 2 पर्सन आहेत, त्यांच्यात कॉम्पिटिशन आहे. फर्स्ट पर्सन स्टार्टेड टू इटिंग दॅट लड्डूज. लाडू खायला पहिल्या पर्सननी स्टार्ट केलं. त्याच्यानंतर 2 सेकंदांनी दुसऱ्यानी स्टार्ट केलं. ऐका, पहिल्या पर्सननी लाडू खायला चालू केलं, त्यानंतर 2 सेकंदांनी दुसऱ्यानी स्टार्ट केलं. पण दोघांचं एकाच वेळेला संपलं. पहिल्याला 9 सेकंद वेळ लागला, तर दुसऱ्याला किती लागला? मग
7 सेकंद.
7 सेकंद लागला ना. आर यू गेटिंग माय पॉइंट? दोघं काय करायलेत? लाडूच काय लागलेत. पहिल्यानी चालू केलं, दुसऱ्यानी कधी चालू केलं? 2 सेकंद उशिरा चालू केलं. बरोबर आहे ना? म्हणजे तुम्ही काय कॅल्क्युलेशन केलं? 9 minus 2 केलं ना 7 आन्सर काढायला. नाउ सेम लॉजिक इज अप्लाइड हियर. फर्स्ट स्टोन इज थ्रोन वर्टिकली अपवर्ड्स. आफ्टर 2 seconds, second stone is thrown. So time gap is 2 seconds. But both the stones are reached to the ground on the same time. So if the first stone, for the first stone it is 9.9 second is the time, then for the second stone you should do 9.98 minus 2. So 7.98 is the time for the second stone. Clear now? Is it clear? समजलं का? So now next, if this is the total time, now this is the total time for the second stone. म्हणजे इथून या पॉइंट पासून निघून वर जायला आणि वरून खाली यायला टोटल टाइम लागलाय. मग सिंगल फ्लाइट मध्ये किती टाइम लागला ते कॅल्क्युलेट करा. दिस इज द टाइम फॉर द सिंगल फ्लाइट. दिस टोटल टाइम इज 7.98. Now the time for the single flight. So the time for single flight म्हणजे फक्त वर जायला किती वेळ लागला, तर इट विल बी 7.98 divided by 2. So what is the time? 3.99 seconds. Okay, so this is the time of flight for म्हणजे हा टाइम किती असणार आहे 3.99. हा टाइम खाली यायला किती लागला 3.99. ह्याचा किती टाइम आहे, वर जायचा हा टाइम किती असणार आहे 4.99. खाली यायचा टाइम किती आहे 4.9. ओके, so now for the second stone, for the second stone, V is equal to U and GT. I will write plus or minus G. Second stone, consider this motion. When you throw on this, it will move to this point. Okay, ही मोशन कन्सिडर करा या पॉइंट पासून इथपर्यंतची. So it is moving in upward direction. We will consider this motion. It will moving in upward direction. So G is minus. G is minus. So here now, if you consider this motion now, in this motion here, your initial velocity is u2. Your final velocity will be 0 and time is 3.99. Okay. So I can write here the final velocity is 0. Initial velocity we don't know the value, let it be u2 for the second stone. It is minus 9.81 g and into time is known to us, it is 3.99. This is the time. Okay. Therefore, what is the velocity now? It is 39.14 meter per second. This is the final answer. So the initial velocity of the second stone, it is calculated now. This is the initial velocity of the second stone. Okay. Is it clear now? प्रॉब्लेम कळलाय का सोडवलेला? सगळं होच म्हणता मला कळतच नाही, तुम्हाला सगळंच येतंय का काहीच येत नाही? आय एम रिअली थिंकिंग ऑन दिस. दोनच गोष्टी आहेत, एक तर तुम्हाला सगळंच येतंय, नाहीतर तुम्ही काहीच करत नाही. ओके, गुड. जर सगळंच येत असेल तर चांगली गोष्ट आहे, आणि काय करत नसताल तर आता करायला तरी लागा. Okay, so this much of numericals are sufficient. Now in the evening I am going to take the lecture at 4. Okay, today evening. आज 4 वाजता EM चं लेक्चर आहे तुमचं. ओके, at 4 o'clock today. कुठला नाही दुसरं. Today at 4 your lecture is there, and in that lecture we will see the next bit in this unit only, the numericals on variable acceleration. We will see the numericals on variable acceleration. Up till now we have seen the problems on linear motion, then we have seen the problems on motion under gravity. Now after this there are numericals on variable acceleration, and after that numericals on angular motion. Then this topic is over. Okay. So today we will stop over here. So I will take the attendance now. Roll number one is present. 2,
Present, sir.
3, 4, 5,
Present, sir.
6, 7,
Present, sir.
8, 9, 10, 11, 12, 13,
Present, sir.
14, 15, 16,
Present.
17,
Present, sir.
18, 19,
Present.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25, 26, 27, 28,
Present.
29,
Present, sir.
30, 31,
Present, sir.
32, 33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36, 37, 38, 39, 40, आवाज कर रहा करो 40, 41,
Present, sir.
42, 43,
Present, sir.
44, 45, 46, 47, 48, 49, roll number 49, 50,
Present, sir.
51, 52,
Present, sir.
53, 54, 55,
Present, sir.
56, 57, 58, 59, 60, 61, so 54 is present. Okay.
25 is present, sir.
25 is present. You can see the screen on which you are able to see the absent numbers. So if anybody is remaining, let me know. So these are the absent numbers for today's lecture. 6, 11, 12, 15, 32, 40, 42, 44, 47, 49, 32 is present. Okay, 32 is present. Anybody else?
Sir, roll number 50 is present.
50, 50 or 15?
15.
15. Okay. Next. Anybody is there who is present? 57. Okay. 13 students are absent. 30 students are absent. So 61, 49, 48, Okay. So in the evening at 4 we will take the lecture. I will take the lecture. You must attend it.